so I'm back with another video, and in this video I'm gonna demonstrate a few more examples on integration by parts using the same general formula as I did in the previous video. So the examples which I'm going to show you today are x squared e to the power x dx. This is the first example. Let's just focus on that for now. So according to the Eilert rule, x squared is fx, f of x is equal to x squared, and therefore f prime x is equal to 2x, and g of x is equal to e to the power x, and therefore g prime x is also equal to e to the power x. So now I just replace these terms in the formula like I did previously, and here is what I'm going to get: f of x into g of x, so x squared e to the power x minus the integration of 2x multiplied with e to the power x dx. So you see what's happening here. We have an integration by parts problem within an integration by parts problem. So we are going to solve this separately and then replace the value inside in place of this term, or we can just do it alone in just one go. That could be done as well, just that we don't have to operate any more on this. Just this term is meant to be operated upon. So here's what we get: x squared multiplied with e to the power x minus so in this case 2x becomes f of x, and hence f prime x is equal to 2. We can consider that, or there is another thing that we can consider. Since 2 is a constant which is multiplied with x into the e to the power x, we can keep it outside the integration. That would make things a bit easier, so that's what I'm going to do. I'm going to keep 2 outside the integration. So this is what we're going to integrate. We have x squared e to the power x minus 2 into x e to the power x dx. This term is what we're going to integrate now. So to generalize it, in this case x is f of x, and hence f prime x would be 1 we have g prime x as e to the power x, which is the same as this. So g of x will definitely be e to the power x. Now we're just gonna use the generalized formula again, and we're gonna integrate this. Here's what we get: x multiplied with g of x, which is e to the power x. So not to forget the 2 minus the integration of f dash x or f prime x multiplied with g of x. So the integration of 1 multiplied with e to the power x dx. That's what we require. So what we have at hand here is x squared e to the power x minus 2 x e to the power x minus, and since it's like minus multiplied with minus, so it's going to be plus 2 into the integration of e to the power x, since it's multiplied with 1, so the integration of e to the power x, which is e to the power x itself, plus c. So take a good look at this, and you can ask me any problems you have in the comment section. If you want to view this any longer, you have to pause the video. Alright, next let's move on to our second problem for the day. Number 2. The integration of cos x into e to the power x dx. Now you might be wondering, why have I interchanged the colors in this? Have I made a mistake? No, I haven't. It's this way. It's supposed to be solved this way. I mean that g prime x would be cos x and f of x is e to the power x in this case. This is an exception for technically like only 2 terms in basic integration by parts. When we integrate either e to the power cos x or e to the power sin x, we're supposed to integrate it in this way, which means that fx is e to the power x and cos x or sin x would be g prime x. That's how we can reach a conclusive answer. Otherwise, we'll just keep repeating, we'll just keep getting back the same term, since the integration of since the differentiation of e to the power x is e to the power x, so we'll just keep getting the same terms again and again, and it wouldn't help at all. And that is why we use this form. So the question is e to the power x multiplied with cos x dx. Now how do we go about solving this? It's going to be the same way, for the exception that in this case we will be following not isolate but isolate, because the exponential is coming before the trigonometrical, so isolate in this case. First, let me use the general terms. F of x would be e to the power x, and therefore f prime x would also be e to the power x. G prime x would be cos x, and therefore g of x would be sin x. And so this is going to be written as e to the power x sin x minus the integration of e to the power x sin x. Sorry for that. Now we're going to have to integrate this again. So you see, I tackled both the problems in the same sum. It's just that if I integrated this, then I would have to get back, then I would have reached e to the power x cos x, which I would have to turn back into e to the power x cos x, as you will see is what is gonna happen right here. So to generalize, f of x is e to the power x, and so is f prime x. G prime x is sin x, and hence the g of x is minus cos x. So the solution is getting clearer. Minus the integration of this, which would be e to the power x multiplied with minus cos x, since there will be 2 minus, so this will become a. In fact, let it remain a minus for now. I will change it in the next step. E to the power x multiplied with minus cos x minus the integration of e to the power x minus cos x dx let me just I will write this down again. On the side, okay, sorry about that. Oops. This is this bracket closing. Now as you can see, this is how it's playing out. E to the power x sine x minus and minus, they become plus. E to the power x cos x. And here there will be 3 minuses involved, so it's going to be minus e to the power x cos x dx, the integration of e to the power x cos x dx. Rather, now you're going to think that we are stuck in a recurring infinite loop or something like that, but that's not going to be the case. You see, we have an equation here. If we take this, the question as the left hand side, and what we have conclusively ended upon as the right hand side, then we can send this, we can add this expression to both sides, and the final expression, the final equation that we're going to get is 2 into e to the power x cos x dx is equal to e to the power x sin x plus e to the power x cos x. Might as well put a plus c. Plus c. So, since I added this to both the sides, this got removed from the right hand side and 2 of these ended up on the left hand side. So now I can just divide both sides by 2 and I chance upon the answer, e to the power x cos x. The integration of e to the power x cos x would be half e to the power x sin x plus e to the power x cos x plus c. This would be in fact because the half is multiplied with both the terms. So yeah, that's it for this video. I will return with a new video very soon. Again, if you have any doubts or problems, feel free to email me or mention it in the comment section. Thanks for watching.